Hi, this is Learn with JEE for you. So today I've got few matrices questions. So these are just basic levels, just to start your JEE preparation. Okay. So the first question is this, as you've seen on the screen, that they have given a matrix A, which is a complex matrix because you can see the imaginary number I. So you should know minimum that I square is equal to -1. That is, I is actually square root of -1, which is an imaginary number. Because till 10th, square root of -1 was like not exist for you. But here we have I as root of -1. So if you square the both sides, you get I square is equal to -1, which most of you might be knowing. So I want to find the determinant value for A. And they have not asked the determinant, they just have asked A raised to 4 raised to n. So first let us do what is A square. So A square is I0, 0I. Again, you multiply two matrices. So how do you multiply two matrices? Very easy. You multiply it this into this, right? So I into I square plus 0 into 0, 0. So you get I square basically. Okay. Then you multiply like this. So I into 0, 0, 0 into I, 0. So that is 0. I'll show you properly. I into I plus 0 into 0. And here I into 0 plus 0 into I. Like that, here this column, this row will get multiplied by this column. So 0 into I plus I into 0. And this row will get, second row will get multiplied with the second column to get the second A22 element. So 0 into 0 plus I into I. So you know this is I square, this is 0, this is 0, this is I square. And as I told you, I square is -1. So -1, 0, 0, -1. This is the matrix. This is A square matrix. But हमको क्या चाहिए? See, you can write this A raised to 4n as A raised to 4 raised to n. तो पहले हमको क्या ढूंढना है? A raised to 4 ढूंढना है. Correct? So for that, I have to next find A cube. So let me just copy this. So this is my A square. Okay. So A cube, you can write it as A square into A. Right? Now A square, I have just copied it actually. So why should I simply write it? Yes, I'll merge that to equal to. And ये I 0, 0 I. है कि नहीं? So again you will have to do multiplication. So -1 into I plus 0 into 0. Then -1 into 0 plus 0 into I. That is, I have multiplied this and I got this element. I have multiplied this and I've got this element. Okay. Now we'll multiply it this way. So that is again 0 into I plus -1 into 0. This is बहुत easy अभी तुम लोगों के लिए. I'm not going into the exact details of how to do it. Okay. Now here, what will happen to the A11 element? It will be -I. यहाँ पे तो 0 ही आएगा, यहाँ पे तो भी 0 आएगा, and again -I. Okay, so this is element. Abhi, can you see a relation between A cube and A? Abhi, we got A cube here, straight, this is A cube. But if I take a minus common out of this matrix, okay, 0 से minus common लो तो 0 ही होगा. तो ये I 0, 0 I, which is basically your A matrix. So you can say that A cube is equal to -A. See, it's clearly obvious. Now, A raised to 4 is what? A cube into A. And A cube के बदले I write -A into A. And A into A is -A square. And A square was what matrix? This matrix was A square basically. So -1, 0, 0 minus 1, and you get 1 0 0 1, which is basically an identity matrix. Okay, so slowly you'll understand this pattern. So you should always try to get a pattern everywhere. In matrix questions, you should try to get a pattern here. That's the main thing. That's the main thing. So you got that a raised to 4 is I. Now what will be a raised to 5 then? You will say, sir, a raised to 4 into a, and a raised to 4 to I hai. And I into a, anything into any matrix is that matrix itself, because it's an identity matrix. It's like multiplying 1 with any number. So you will get a back. And a raised to 6 will be what? A raised to 5 into a, which is a raised to 5 is a itself. So a into a square. So can you see again, you are repeating the pattern. It's like this: a square, a cube, a raised to 4, and then again a raised to 5 is just like a, then a raised to 6 is just like a square, and so on. It repeats. A raised to 9 will be like this. So basically you can say a is a periodic matrix of what period? Period 4, because after 4 it's repeating, the values are repeating. So a is a periodic matrix. A is a periodic matrix. Now you can see for all the multiples of 4, is going to be the same value. So what is the meaning of a raised to 4 raised to n, where n is a natural number? A raised to any multiple of 4, and that was similar to a raised to 4, and it's similar to the identity matrix. No, it's exactly like the identity matrix. So any a raised to any multiple of 4 is a raised to 4 raised to n, and that is what your identity matrix. Okay, I hope you have understood the pattern. What we started with a square, because we knew that we have to reach a raised to 4. So we started with a square, we got this matrix, and then again we found a cube by again multiplying with a, and then we stumbled upon that a cube is just like minus a. So from there again I don't have to multiply, I just have to multiply. I make sure that a raised to 4 is a cube into a, and a cube to minus a here. So I multiplied minus a into a minus a square, and a square was just the negative of the identity matrix if you observe. So minus of a square will be give you new identity matrix. From there on you understand there is a pattern. There's a pattern. So it's a periodic matrix, and for all powers of multiples of 4 you get identity matrix itself, and that is what they were asked. So this is the answer. Okay, I hope you understood. Let's go to the next question. So here A is an n-rowed square matrix, and they are asking you to generate every element using this formula. Now you might be knowing, who doesn't know, but you might be knowing what is the greatest integer function. Greatest integer function is the greatest integer which is less than equal to x. Okay, so suppose if I say 2.67, greatest integer of 2.67. So if you see in the number line, 2.67 is between 2 and 3, and 2.67 is here. So I am asking you which is the greatest integer which is less than equal to this value. So less than equal to this value, which is the greatest integer of all the integers, 2. So this answer is 2. Suppose if I ask you like this, minus 2.67 का greatest integer क्या होता? So again you have to draw the number line and be very careful. Minus 2, minus 3. So here minus 2.67. Now again I am asking, saying the greatest integer which is less than equal to that particular value, that is whatever is inside the square bracket. Square bracket denotes greatest integer function. तो जो भी अंदर है, okay, just imagine the greatest integer. There will be a lot of integers, but the greatest integer which is less than or equal to that x in the number line, so which is the greatest, minus 3. So understand, it is minus 3. And if you take any integer, then what will happen? Suppose if I say greatest integer of 2. So greatest integer of 2 means you will want all the greatest integer of all the integers which is less than equal to 2. So 2 is also included, less than equal to बोला है. according to definition of greatest integer. So it is 2. So what is minus 2? Greatest integer function of minus 2, that is also minus 2. Okay, so this is the concept of greatest integer function. Okay. Okay, so let me just resize this concept. So this you might have studied in function chapter, what is greatest integer. So let us apply this concept in matrices to get every element. Okay, तो यहाँ पे तो first I divided by j का greatest integer function. Now you tell me if I is less than j, that is if j is greater than I, so this value whatever is inside will be 0 point something, है कि नहीं? मतलब जब न्यूमरेटर कम है और डिनोमिनेटर बड़ा है, फॉर एग्जाम्पल if I say 1 by 2, or take any number in the denominator 5, but you take a number which is less than that 5, 4, this is anyway going to be less than 1, 0 point something something होने वाला है. And what is 0 point something something का greatest integer function? 0, because as I told you 0 1, so 0 point something will lie here, so the greatest integer which is less than equal to that value is 0, because 0 is also an integer. So for any where for any element which is j is greater than 1, you get 0 direct. Okay, so if that is the case, it's very clearly obvious that when j is greater than 0 मतलब कहाँ है? अभी ये diagonal elements हैं. So this is a11, this is a22, this is a33. I'm just giving you an idea. a44. So यहाँ पे a12, a13, a14, a23, a24. I'll just draw it properly. a34. Okay, and yeah. So these elements here, you can say that your j is greater than I. So all these elements are 0, 0, 0, 0. So it's basically a lower triangular matrix. What about diagonal elements? With diagonal elements के लिए, you can say diagonal elements I is equal to j, right? So greatest integer function of I by j will be what? It will be basically greatest integer function of 1, because I j के बराबर है, the same value, like 4 by 4 is 1, 5 by 5 is 1, so this is 1. So now all the diagonal elements are going to be 1, 1, 1, 1. And obviously these will have values, ऐसा नहीं है कि नहीं होने वाले, 1 होगा, कि more than 1 होगा, 2 maybe. That is not our concern. Now we have solved the problem actually. Just with this data we have solved the problem. Now I'll give you an understanding why it is like that. You take any upper triangle or lower triangle. Now here our concern is lower triangular matrix. So you take any lower triangular matrix. First I'll take a 3 by 3 example. 1, 2, 3, 4, 5, 7, and here पे 0, यहाँ पे 0, यहाँ पे 0. Okay. Now if I want to find the determinant value of this, so A is like this. This is A matrix determinant value. What will you do? You will definitely open like this. And if you open like this, 1 and 2, you will get again this this will be your minor. So 2, 0, 7, 3. Right? And this will be again, if you see, since this is 0, you can only multiply like this, right? So finally you will be 1 into 2 into 3. Now what if you get a 4 by 4 matrix? I'll just show you to get the feel, okay? But now I cannot show more than that. 4, 2, 0, 0, 3, 7, 3, 7, 8, 0, 9, 2, 2, 1. So this is an upper triangular matrix where the diagonal elements are this, right? Now I want to solve this. I want to find the determinant of A. So कैसे करेंगे? 1 and 2. I'll open like this, 1 and 2, and then you will get the entire this will be your cofactor, right? So this will be 2, 0, 0, 7, 8, 0, 2, 2, 1. Now यहाँ पे कैसे खोलोगे? ऐसे ही खोलने वाला है. So again 1 and 2, 2 and 2, and this will be the cofactor there. So then 8, 0, 2, 1. Now since this is 0, you will just have to do 8 into 1. So 1 into 2 into 8 into 1. That is the answer. And voila. In a diagonal matrix, upper triangular or lower triangular, जो भी है, in a triangular matrix, the determinant value will be exactly the product of all the diagonal elements. Just take the product. Blindly take the product of the diagonal elements. तो यहाँ पे determinant see 1 into 2 into 3. यहाँ पे determinant will be 1 into 2 into 8 into 1. See? It's simply the product of the diagonal elements. Blindly you can take, that will be the determinant value. If it is upper triangular or lower triangular. मतलब जो ऊपर वाला पूरा 0 है ऊपर ट्रायंगल का और यार नीचे वाला ट्रायंगल जो भी केस हो, यहाँ पे तो लोअर ट्रायंगुलर का एग्जाम्पल दिया गया है, बट इट कैन बी अपर ट्रायंगल ऑल्सो. द डिटर्मिनेंट विल बी जस्ट द प्रोडक्ट. लाइन में पूरा प्रोडक्ट ऑफ डायगोनल एलिमेंट्स ले लेना. ओके, सो आई एम जस्ट राइटिंग दैट पॉइंट. इन एनी अपर or lower triangular matrix, okay, determinant is equal to the product of all its principal diagonal elements. Principal diagonal वही diagonal जो है, principal diagonal बोलते हैं इसको, diagonal भी बोलते हैं, principal diagonal elements. Very important point. Okay, now let us go back to this question. So यहाँ पे I told you the principal diagonal elements all are 1 1 1 1 1 1 1. तो इसका determinant will be exactly 1 into 1 into 1 into 1. That's why I told you इससे कोई मतलब नहीं है. You're getting? I just needed to verify that it's a lower triangular matrix because the upper triangle is completely 0 and the diagonal all are 1. That's it. उसके बाद तो आंसर हो गया. So the answer is 1. Okay, I hope this is clear. This concept is important. Now यहाँ पे the product of n matrices is given. So there are n matrices like this, and you know there are n matrices because if you observe this element, these three elements are same in everywhere. क्या change हो रहा है? 1 2 3 कितने कहाँ तक जा रहा है? n तक जा रहा है. तो obviously total number of elements are n terms. So that's also verified. Now they are saying that इसके sum इसकी product of is going to be equal to this. And it's quite obvious कि ये जो element है, since it's not changing and it's 1 and 0, simply finally answer में भी ये वही आने वाला है. तो think कि this is going to make it 370. So how to bring a relation? So let us see. First let us take the product of these two. Okay, 1 1 0 1 1 2 0 1. Okay, now since you know all this, I'm going to multiply like this. So 1 into 1 1, 1 into 0 0. So finally it will be, here it's going to be 1. Okay, and here I can multiply like this. So that will be again 2. 1 into 2 plus 1 into 1. So ऐसे आएगा 1 plus 1. Correct? And the remaining here is going to be 0. Here it's going to be 1. It's quite obvious. Now this one 1 2 plus 1 0 1. Again I'm going to multiply it with this 1 0 3 and 1. तो क्या आने वाला है? Check करो. This will get multiplied with this. So 1 into 1 and this into this whole thing will become 0. So 1 ही आ रहा है. And यहाँ पे भी 0 1 आएगा. It's quite obvious. I'm not going into that. So now this into this will give you what? 1 into 3 plus 1 plus 2 into 1. So you'll get 1 plus 2 plus 3. So see, it keeps on keeping on adding. It's keeping on adding. It's keeping on adding. See, basically the product of the first three terms is basically what? The sum of all this. So if you take till n, if you take it till n, what is going to happen? 1 0 1 1 plus 2 plus 3 like that till n. Sum of first n natural numbers मिलेगा इधर. And वो तो पता है from sequence and series 1 0 1, it is n into n plus 1 by 2. and you have to compare it with your answer. So 378. So basically n into this term and this term should be equal. So n into n plus 1 by 2 is equal to 378. Okay, and from here I think easily you can solve it. So I'm just going and this is a quadratic equation. So n square plus n is equal to 2 into 378. So n square plus n minus 2 into 378 is equal to 0. So now you have to factorize in such a way the product is this and the difference of the two numbers is 1, because यहाँ पे negative है ना, इसलिए यहाँ पे negative है, इसलिए the difference of the two numbers should be 1. So you just have to factorize in that order way. So 378 लेंगे, right? So this is divisible by, so I'll just do one thing. I'll make it 4 and 2. I'll divide this by 2. So 18, 189 आएगा. ये 9 है, ये 9 पे जाएगा, है कि नहीं? So I'll take 9. So 36 into 21. Difference is not 1. Okay, so 9 into 4 into 3 into 7. ऐसे कुछ got it. See? So here it is 28 into 27. Difference तो 1 हो गया. So it will be n square plus 28n minus 27n minus 2 into 378. Now I think you know how to factorize. n into n plus 28. यहाँ पे भी n plus 28 तो आना ही है, तो minus 27 आएगा, क्योंकि minus 27 into n will give you minus 27n. So n minus 27 and n plus 28 is equal to 0. So n is 27 or minus 28, right? So n is equal to 27 is your answer. This is obviously rejected क्योंकि negative है. Okay. See, this problem, everything was very easy. Understand? See, they have given, when they give you product of n terms like that, just like that, understand there should be a pattern. Otherwise, तुम ऐसे करते करते कैसे कितना तक जाओगे? So there is a pattern. So that's what I understood. For the first 2 or the 3 products, you will understand a pattern. And here I understood the pattern that it was adding up the numbers. What was in the A12 column. The A12 element is getting added up. Since other elements are all going to be the same, because you can see the answer also is going to be the same. तो वहाँ पे worry करने की ज़रूरत नहीं है. So A12 element is getting added up. And simply there are n terms, so you just simply add the values. It's coming in order 1, 2, 3. It's like sum of n natural numbers which are related to a formula, and equated it and solve the quadratic. Okay, so this is the idea of the entire thing. So यहाँ पे भी मैंने ऐसे normally factorize किया. Okay, so let's go to the next problem. So here they are saying A is equal to 1, 2, 3, 4. And that is A0, 0B. Okay, AB is like that. Then they cannot exist in AB. Achha, so we have to basically check. So this is not equal, sorry. This is B is equal to this. And they are asking that if they commute each other. Commute to each other मतलब A and B, A into B is equal to B into A. वो हमेशा होता नहीं है, but in certain cases होता है. So that time they are saying that कि commute each other है. So what is the exact condition? How many such possible values for D do you have? तो करते हैं एक बार. A B करते हैं. A into B. 1, 2, 3, 4. And here A0, 0B. So what do you get? Now I'll directly do it, because I'm just multiplying this. That's it. Very easy. So A, and this I'm going to multiply. So 1 into 0, 0, but it will be 2B here. And this into this. So 4 into 0 to gaya, doob gaya wo 4. So you get here 3A, and this into this, 3 into 0, doob gaya 4B. So this is your AB. Now let us do BA. And then you have to equate both. Okay, let's multiply this into this. So 0 into 3, 0. So you'll get a back. Now this into this. So 0 into 4 to gaya. Again you get 2a. And this into this. 0 into 1 to 0. But you get 3b. Now this into this. 0 into 2, 0. But 4, you will get here 4b. Okay. Now they are saying that what are the conditions for AB is equal to B. तो दोनों बराबर equal है कि नहीं पर पहले check करते हैं. Okay. So this is your AB and this is your B. Okay. Now check. This is equal to this. So that is direct. 4B is equal to 4B. Direct. हम कुछ नहीं बोल सकते क्योंकि both are exactly the same. But here they are saying 2B is equal to 2A. 2A is equal to 2B. That is A is equal to B. And here 3A is equal to 3B. Same. 3A is equal to 3B. Same result I am getting. That is A is equal to B. A is equal to B. So basically you can have infinite type of matrices. Only condition is these two have to be equal. Like that, how many real numbers are there? Sorry. बहुत सारे numbers है. 1 1 satisfied, 2 2 satisfied, 4 4 satisfied. ऐसे कितने possibilities है? Infinite. ऐसे infinite possibilities है. तो this is my answer. I hope I'm clear. So we have proved that if A is equal to B, you have infinite types of solutions for B. Okay. Okay. This is the last question for today. So they have told there's a matrix which is, this is very easy. R into R minus 1, R minus 1, R. And they're asking determinant of 1, determinant of 2. यहाँ पे R 1 है, 2 है, 3 ऐसे 2006 तक. So if I want to find the determinant of AR, directly you can do it. R square minus this. So directly you will get R square minus R minus 1 whole square. Okay. So determinant of A1, I can write it as 1. I'll write it here so that it is easy to show you. Determinant of A1 is 1 square minus 1 minus 1 whole square. Okay, which is basically 1 square minus 0 square. So basically whatever number is here उसका square आएगा इधर. Okay, and whatever number is here उसका एक कम हो गया इधर इसका square. So 1 minus 1 0. Like that. Determinant of 2 will be 2 square minus 1 square. And determinant 3 will be 3 square minus 2 square. ऐसे ऐसे करके last में determinant of 2006 will be 2006 square minus 2005 square. तो ये बहुत कॉमन सीरीज है आईआईटी में. तो यहाँ पे कैंसिल होते जाते हैं. देख ऐसे ऐसे कैंसिल होते जाते हैं. बट कैसे कैंसिल होता है वो दैट इज ऑल्सो वेरी इंपॉर्टेंट टू अंडरस्टैंड. तो फर्स्ट यू शुड अंडरस्टैंड कि हियर आई विल यूज डिफरेंट कलर्स फॉर दैट. लेट अस फोकस ऑन अटेंशन ऑन दिस एलिमेंट. Okay, so I've cancelled 1 square. Now 2 square is also getting cancelled, so I'll put a different color. Yeah. Now understand, the left hand side of every element is cancelling with the previous term. Okay, the left hand side of every element is cancelling with the previous term. If you observe, see, left hand side is cancelling with the previous term. Sorry, my bad. The right hand side is cancelling with the previous term. The right hand side is cancelling with the previous term. Okay. And the left hand side is cancelling with the next term. The left hand side is cancelling with the next term. And the right hand side is cancelling with the previous term. But first term का कोई तो previous term है ही नहीं, तो उसका right hand side will be intact. वैसा ही रहेगा 0 square. Now left hand side is cancelling with the next term. But ये जो लास्ट टर्म का है नेक्स्ट टर्म है ही नहीं, तो उसका लेफ्ट हैंड साइड इंटैक्ट रहेगा. सो यू कैन कैंसिल एवरीथिंग एंड यू कैन कैंसिल द राइट हैंड साइड ऑफ 2000 indeterminate 2006 because there is the right hand side cancels with the previous term है उसका, right? So what is remaining? This is remaining minus 0 square and 2006 square. So finally when you add it up, so determinant A1 plus determinant A2, I'm just adding it up, plus determinant A 2006, sorry, let me write it neatly, sorry for the bad calligraphy, is equal to 2006 square minus 0 square, which is basically 2006 square, which is this. So it was just a matter of opening it up and finding the pattern and then cutting it out. This series is very common in JEE, so I think you might have done it in trigonometry, ITF, all those things. Okay, so thank you.